In this unit, we're going to learn about percent composition and how it relates to moles. And moles is a concept we'll learn and talk about in the next lesson. But for today, we're talking about percent composition. So percent composition is where we take the percent of each element in a compound and we tell how much of each element is present in the compound. If you recall, the equation for a percentage is part over whole times 100, right? And so when we're talking about compounds, we're looking at the same kind of thing. Only thing is that the part is the element, right? The element is the part, and the whole compound, that's the whole, okay? So when we're thinking about percentages in terms of compounds, that's what we're looking at. The element is the part, and the compound is the whole. So let's look at this example. So we want to calculate the percent composition of ethane. And we do this all by mass. And we can find the mass of all of these elements, of course, on the periodic table. So we want to have our periodic tables out, right? And we can look up the mass of carbon on the periodic table, and we will find that the mass of carbon is 12.01. Now there are 2 carbons, so we must multiply that by 2. And that is 24.02. And then for our hydrogen, that has a mass of 1.008, there are 6 of those, so we have to multiply that by 6. And so we get 6.048. Great. So then to get the total mass, we would add that all together. And we would get 30.68. Sorry, 068. Now that is the total mass. So this would be our whole, right? That's the mass of our whole compound. So to find our percent, right, for carbon, we would want to take the mass of our carbon, and that's all of our carbons, which would be 24.02, and divide by the whole mass of the compound, which would be 30.068. And then, of course, we multiply that by 100. So we get 24.02 divided by 30.068, multiplied by 100, and we get 79.89% carbon. Right? So now we have to find the percent of hydrogen. Whenever it says just find the percent composition, we need the percent of each element. So carbon and the percent of hydrogen. There's 2 ways you can do the percent of hydrogen. You can, of course, just subtract your percent of carbon from 100, because all percentages should add to 100. And then you can also set it up like we did the carbon, where we put the total mass of the hydrogen over the whole. So we're going to do that, total mass of hydrogen over the mass of the whole compound. And again, we would multiply by 100, and this is for our percent of hydrogen. So and we get 20.11%. Right, so our percent composition would be 79.89% carbon and 20.11% hydrogen. All right, let's look at another kind of problem. All right, in this one, find the percent composition of a compound containing tin and chlorine if 18.35 grams of the compound contains 5.74 grams of tin. So again, the percent composition is looking for us to find the percent of tin and the percent of chlorine. So we can certainly find the percent of tin because we have the mass of tin and we have the total mass of the compound. So the percent of tin would be 5.74 grams of tin divided by the total, which is 18.35 grams, and then multiply that by 100, right? And we get 31.28% tin. Now to find the chlorine, we could calculate and figure out what is the mass of the chlorine, or we could just subtract this from 100 because the total percentages must add to 100. So to get the percent of chlorine, we could take 100 minus 31.28%, and that would give us 68.72% of chlorine. And so our answer would be 31.28% tin and 68.72% chlorine. Let's look at one more type of problem. And sometimes we don't want to find the percent of all the elements. Sometimes we just want the percent of one. So in this problem, it says calculate the percent of nitrogen in this compound. So again, to find our percent of nitrogen, we would need the mass of nitrogen. So in this instance, we have just the one nitrogen, which is a mass of 14.01 from our periodic table. And then we add up the mass of all of the other elements. So we have 12.01 for carbon, right? Oxygen, there's one of those, would be 16. Our nitrogen, of course, is 14.01. And then our hydrogen is 1.008, and we multiply that by 2 since there's 2 of them. Then we add all that together. And we get 44.036. So that would be our total here. And then, of course, we take 14.01, divide by the total, and multiply by 100. And we get 1. We get 31.81% nitrogen. Okay. All right, so you try this one. Go ahead and pause, try this problem on your own, and then return. Keeping in mind that this has 3 elements, so you have to find the percent of lead, sulfur, and oxygen. All right, so in order to find the percent composition here, we need to find the percent of lead, sulfur, and oxygen. So at first, we need to know what the total mass would be, right? So we find lead on the periodic table, and we find it has a mass of 207.2. And sulfur has a mass of 32.07. And then oxygen is 16, but there's 4 of them, so we have to multiply that by 4. And then we add all those together. And we get 303.27. So that is our whole. All right, so for each one of these, we take the mass of lead, 207.20, divide by the total, 303.27, of course, multiply by 100. Same for the sulfur, we'll put our 32.07 on top, and our 303.27 on the bottom, again, times 100. And then our oxygen will have to be 16 times 4, right? And then that's over 303.27, again, times 100. And so we plug all those in and calculate. Right, and we get the first one, 68.32%. For the second one, we get 10.57%. And for the last one, we get 21.10%. And of course, you can check yourself by adding all them together, and you can determine that they should all add to 100. So as long, again, we rounded, so if it comes out to 99.98, that's fine. All right, one more. Again, pause, and you try this one. All right, so in this one, we just want the percent of oxygen. So to find the percent of oxygen, we take the mass of our oxygen and divide by the total mass of the compound. Since our compound has 16.32 grams of chlorine and 3.68 grams of oxygen, then our whole compound, right, has a mass of those two added together. So that would be 16.32 plus 3.68. So our whole would be 20. So we would divide by 20 grams and then multiply by 100. And we would take our 3.68, divide by 20, and multiply by 100. And that gives us 18.4% oxygen. All right, now I want you to go to this bit.ly here, and I want you to solve the problems in that Google form to show your understanding of this lesson and that you've completed this assignment. And I will see you in class next time.